Hey guys, it's Brandon. Welcome back to Young Kingmakers. This video is going to be a little different from the ones that you've seen on this channel so far. At the start of last year, I started compiling data, evidence about depression that I believed would help people understand it so that they could see that it wasn't outside of their control as much as mainstream sources often say that it is. My goal was to write a book about it called The Way Out, but it never got past the final draft stage. But what I hope to do is share that research with you now so you can be better informed about depression, especially right now when quarantine may be causing increased rates of stress, anxiety, and depression. The format is simple. First, I'm going to show you data. Then I'll highlight any reasons I found why this data was kept from your knowledge. At the end, and feel free to tune out if you're not interested, I'll share how learning this information impacted my own understanding of depression and any implications that arose from that. I have a love of investigating mental health problems that started in college when I wrote about something I have, Tourette syndrome, and found that almost everything that I was taught about it was wrong. Since then, I've explored other mental health issues like depression and anxiety to find out what we have right and what we don't have right. My goal isn't to change your mind. Your mind is not mine to change. My goal is to share knowledge for knowledge's sake. Whatever conclusions you draw from it are your business. Let's start by swinging for the fences and take a look at the idea that genes cause your depression. The idea that genes cause depression has changed a lot over time. At one point, we as a people thought that there was a specific gene for depression and that it was something that could be inherited. This line of thinking traces back to the time of Abraham Lincoln, if not earlier. Lincoln's parents and other relatives exhibited signs of depression, much like he did, and that familial connection was enough to ask the question of depression being heritable. That single gene idea changed over time, eventually becoming that depression was not relegated to one gene. Instead, it was a result of multiple genes being expressed in certain ways. As this idea was researched, it too was replaced. Now where we currently sit is that, at best, what people inherit is a genetic predisposition to being sensitive to environmental factors. This is a far cry from claiming that someone's depression is caused by their genes, an idea that kind of discreetly implies that you're helpless to change what you are on a molecular level. But that itself means a lot. Where did the idea that you can't change your genes come from? Is it wrong? On the sunny London morning of September 19th, 1957, on the third day of the Society for Experimental Biology Symposium on the Biological Replication of Macromolecules, Francis Crick would present for the first time the core foundation of genetics we use to this day. With only an hour to share his magnum opus, Crick explained at breakneck speed how genetic information could be passed between strands of DNA, then DNA to RNA, then RNA to RNA, and lastly, RNA to protein. Once genetic information entered a protein, it could not return to the DNA. Crick named this idea the central dogma. The central dogma is what forms our understanding of genetics in the sense that what we are is an expression of our genes. Our eye color, hair color, height, weight, sound of our voice, predispositions to certain diseases, and in some observations, even trauma, is ultimately the result of the sequences of nucleotides that make up DNA. This genetic information cannot be changed. It can only be expressed as proteins in the body. It's also why there is the looming question of what we can do about depression if it's stuck in our genes. After all, if there is nothing we can do to affect our genetic makeup, what we're stuck with are bad genes, and all we can do is manage the symptoms. But the central dogma wasn't the whole picture. At the time, Crick's idea was revolutionary. It completely explained one of the greatest mysteries of biology in a way that made sense. Seeing molecular biology through the lens of the central dogma worked, and it was utilized as a foundation for a deeper understanding of genetics. But the understanding of genetics Crick had to work with was limited. This reality was something he was not blind to. By his own admission, the foundation for the understanding of molecular biology we still use to this day was hypothetical in nature, with direct evidence supporting it being, in his own words, negligible. The central dogma was speculative. It was a formula or a tool to help explain other complex issues researchers were tackling at the time. The opening statement of his landmark lecture in 1957 reflected this in the disclaimer, "There is little direct evidence to support this, but to my mind, the psychological drive behind this hypothesis is at the moment independent of such evidence." This was a mistake made by the historical textbooks and the science upon which our understanding of genetics was based, not Crick himself. The central dogma was not just considered an idea, it was accepted as proven fact. The effectiveness of the central dogma in explaining the relationship between DNA and proteins was so effective, it didn't warrant being proven. This scientific oversight, in Crick's opinion, was justified based on the practices of a different field of science altogether. He appealed to cosmology, and pointed out how cosmologists would create theories about space without any experimental data being available either, and that their theories were accepted without question. Crick challenged others to try to create a useful theory of protein synthesis without it, predicting how such exercises would end in the wilderness. Essentially, the central dogma needed no scientific evidence because it proved itself. This does not mean the central dogma was incorrect. It just wasn't the whole picture. The belief that it was is what's now being challenged, and doing so may show us answers about depression not available to us before. Experiments to prove the central dogma also came to the conclusion that there was a large piece of the puzzle Crick unknowingly left out of the relationship between DNA and proteins, and that is that that relationship is a two-way street. This is the world of epigenetics. Epigenetics is not a new science. It may be one of the latest buzzwords in the arsenal of New Age philosophers and motivational speakers, but it is by no means anything revolutionary or cutting edge. In fact, knowledge of epigenetics predates Crick's central dogma by nearly 30 years, coinciding, in a tongue-in-cheek sort of way, with the Great Depression. In 1930, American geneticist Hermann Joseph Mueller, working closely with experiments first set in motion by Thomas Hunt Morgan, observed how exposing a particular type of fruit fly to X-rays would result in the fruit fly exhibiting changed body structures, such as different eye color or wing shape. Mueller knew that for every change that was visible, there were more that weren't, and it was these invisible changes that really caught his attention. In a way, Mueller's and Morgan's experiments with the Drosophila fruit fly were clinical tests of how environment shapes genetic expression, the idea upon which the field of epigenetics is largely based. The underlying question epigenetics seems to be trying to answer is, how does the environment around me affect who I am? As philosophical as this question may sound, it pairs nicely with exploring genetics. First things first. Can the genetic information used to code a protein find its way back into the DNA? No. Once the process is finished and the protein created, the genetic information cannot be changed or reversed, no more than cooked food could go back to being uncooked. The process is finished, and this particular genetic expression is permanent. But your body as a whole is not. Your body is a collection of trillions of cells working tirelessly behind the scenes. Every day, billions of these cells die off and get replaced. You are constantly losing cells and manufacturing their replacements. This means that, in addition to the normal process of cell division, your body is actively creating and using new cells. No matter your age, you have stem cells within you, waiting to be assigned a function. Every one of these stem cells is genetically identical, a blank slate waiting for programming. What does the programming? In a large part, the environment. Not just what you think of when you hear the word environment, but also the location of the cells in the body. It wouldn't make sense for your body to make tongue cells on your bones. But this is the two-way street that completes the central dogma. The environmental signals are passed to the DNA in the cell's nucleus and alter the way that the DNA is expressed. This is a process known as signal transduction, and it's responsible for slight alterations to your genetic expression throughout life. This is where you have more control than you think. To show how, we've got to examine the process of signal transduction and how it changes the way your body reads your genes. Before we do, a quick pause. If you appreciate this type of content, please consider liking and sharing this video, as well as doing all the normal YouTube things like subscribing and commenting. I'd like for this channel to become a hub of transformative information, spanning physical, mental, and spiritual paths, the kinds of which actually have the power to reverse the negative trajectory that a lot of us feel the world is on. It's my hope that Young Kingmakers gets huge, but it can only do so with your help. I can't stress enough how important you are. Never forget that. Okay, back to epigenetics. First of all, it's worth noting that despite its age, epigenetics is still a hotly contested area of study. What we're going to talk about will not get into the more contested details, but rather we're going to look at how the existence of the whole field can change the way we look at understanding genetics and depression. There's a false belief that's widely circulated that your genes turn on and off. This isn't what genes do. A gene isn't a switch, it's a blueprint. It's a blueprint your body reads to create new proteins, and the actual blueprint itself is your DNA. Let's talk about DNA for a second. A single strand of DNA is about 6.5 feet long, or 2 meters. It's comprised of a double helix spiral that is composed of 4 nucleotides, the building blocks of DNA: adenine, thymine, guanine, and cytosine. If you were to uncoil the DNA from its double helix, you would get 2 strands of RNA. Each RNA is the specific pattern of A, T, G, and C, and it's that pattern of A, T, G, and C that makes you who you are. Now, 6 feet of DNA is a lot of information, so your body has an amazing way of packaging it. It creates what's called a scaffolding protein, basically a different protein that your DNA actually wraps itself around. Think of a vine wrapping around a trellis frame. DNA begins to coil around these scaffolding proteins known as histones, and what was once a thread becomes a string. Your body adds more scaffolding proteins, and that string begins to coil around itself again and becomes like yarn. Repeat this process with more histones. The yarn becomes thicker yarn, then it becomes a rope, then a series of ropes. Repeat and repeat and repeat this process until the one long strand of DNA becomes so tightly wrapped that it becomes the very thing wrapping itself, and it forms a particular shape, what we call a chromosome. You have 23 of these in every cell in your body. Every cell you have has all of your DNA on it. Bone, hair, eye, muscle, fat, everything. All of it is genetically identical. However, your body needs some cells to do certain things, to be certain things. That will affect what parts of the DNA in that cell are read, and that will turn the cell into something unique, bones, muscles, etc. When your DNA needs to be read, it goes through a process known as acetylation. The DNA unwraps from the histone, opens up, and an external RNA strand reads the DNA like a blueprint and carries away that information, which is then used to create a protein. This is a process known as transcription, and is way more complicated than what I just described. The process your body uses to block other parts of your DNA from being read is where we find the connection to depression. These processes are methylation and histone modification. Methylation is when a group of molecules, a methyl group, attaches to a part of your DNA. That DNA's pattern is now different, or so the RNA coming to read it will find. It's like if you took the bottom of your shoe and saw its specific pattern, but then you took a piece of tape and put it at the bottom of your shoe. It changes the visible pattern. Histone modification changes the shape of the scaffolding proteins to make other parts of your DNA accessible or inaccessible. The key idea we need to take away from this is, what is available is what gets transcripted. Your body can't create a protein from a blueprint it can't access. Most of the DNA in any given cell is ignored for obvious reasons, but where the area of exploration is, especially in the work of Dr. Bruce Lipton as of late, is in what influence you have over the smaller details of the way your genes express themselves. Here's where epigenetics fits into all this. Epigenetics is how your parents' and grandparents' life decisions affect the way your body reads your DNA. For the people who follow Bruce Lipton's work, epigenetics also refers to things you can do to change the environment around you, which alters the signals that are transferred in the process of signal transduction. That, in turn, alters the way your DNA is read, and this alters your genetic expression. These are some pretty big leaps that mainstream science hasn't yet caught up to or verified, which is why the common understanding of epigenetics centers around how your parents' and grandparents' decisions affect how your DNA is read, methylation and histone modification being how that's done on a molecular level. Now, is such a thing actually possible? Can their life decisions affect the way your body reads your DNA? Yes, you can actually inherit a predisposition regarding how your DNA is read, especially if your parents or grandparents dealt with trauma before you were born. Research from Emory University School of Medicine in 2013 pointed to how the offspring of mice who had traumatic experiences shared their ancestors' aversion to the source of the trauma, even though they never experienced it themselves. According to the article written on the study, mice whose father or grandfather learned to associate the smell of cherry blossom with an electric shock became more jumpy in the presence of the same odor, and responded to lower concentrations of it than normal mice. There's still some debate as to how exactly this happens, but it is enough to say that there's evidence that you can inherit traumatic memory. If epigenetic influences tell us anything, it's that the answer may be in what parts of your DNA get transcripted. This brings us to the conclusion of the video, and my own personal take on these. There are aspects of depression that are genetic, sure, but that's not the end of the story. Common wisdom would say that your genetics aren't something you can alter. Who you are is and always will be just an expression of your genetics. Certain companies stand to make a profit when this idea is kept mainstream. But there's so much that's working in your favor when you look at the situation epigenetically. The process of signal transduction can alter the way your genes are read, and knowing that pulls the rug out from under anyone who says the only thing you can do about genetic depression is to take antidepressants. It also means that there is way more credibility we need to give to how your environment shapes your psychology. You may not be able to do much as it relates to the genes your grandparents and parents gave you, especially if in those genes there is traumatic memory you've inherited. But that's okay. There is power in knowing you have the ability to take what they gave you and shape yourself in a new way, all the way down to the genetic level. It is possible to alter what your parents gave you, but to do that, we can't rule anything out, nor can we throw in the towel. Doctors worldwide will tell you how the people who believe in themselves and in their recovery process heal better than people who don't. And in my opinion, this same idea can be applied here. Information is one thing. Believing in your capabilities is another. What you tell yourself is the catalyst that will create the biggest change, and it'll align the seemingly unmovable factors in your direction, however slightly. This is an anabolic switch. Anabolic here referring to the constructive biological processes in your body. If you really stop to think about yourself, you see that who you are is the king or queen of a 68 trillion cell nation. You are a superorganism, and the things your nervous system thinks about will be carried to each member of your kingdom as though they were laws. The cells, your subjects, will obey those laws to the best of their abilities. In fact, they never fail. You might not be able to control what kind of kingdom you got from your parents, but its inhabitants are still looking to you as their leader. It's a position you were born for, and one where you can quite literally make a world of difference. So what if you feel as though you've inherited your depression? You also have the key, epigenetically, to do something about it. Guys, thank you so much for watching this video. I hope you gained something from it. If you would like to share this video with somebody you believe would be positively impacted by it, it would mean the world to me, and it would mean the world to them. So take that leap, do something to help somebody else today, share this video, like it, do anything you want with it. I will see you in the next one, and as always, I'm so thankful you're checking these out. This is Brandon, this has been Young Kingmakers. See you next time.